Hey guys, today I'm going to talk about the pipeline, specifically how do we turn data and hopes and dreams into a nice triangle on screen. That's the goal. So shiny. I'm going to start by giving you a little bit of a broad overview of the individual steps. First we have vertices. And whichever data comes with the vertices, so for position is most likely one of them, and normal or whatever really we want to include as data on these vertices, we decide that part. So that's step number one, the data, or I call it just the mesh. I call it mesh data. Then we have the draw call. So I'll do draw call. Here all the vertices get joined together into triangles. So we will take vertices and group them up into triangles. And that's specified in the draw call. Then these groups of triangles gets passed into the shader. The shader. And the shader takes groups of vertices and, transforms them where they're supposed to be on screen. So, if they're rotated or scaled or what have you. And then also fills in the pixels to say, how is this triangle gonna look? It's gonna apply lighting or shadows or whatever sort of funky effects we want to make. That's all done in the shader. All right. So these are the three fundamental steps of drawing just a triangle, simply speaking. So let's take one step at a time. What's the mesh data? So we'll do mesh data. Let's talk more specifically in OpenGL context what we need. So first of all, we need someone to store somewhere to store the data. So we're gonna have just some piece of memory where we're storing the data, like that, on the GPU, and we store it using Vertex buffer objects. Vertex buffer object. And a vertex buffer object is just a piece of memory on the GPU where we can store whatever data we want. It can be floats, it can be ints, it's up to us. It doesn't know anything about what type of data it is, it doesn't know anything about really vertices in general. It just knows that I'm a piece of memory, I hold stuff, put stuff in me. Great. And then this data needs to be mapped in some way to vertex attributes. All right, so we're gonna make attributes. And attributes it's just whatever we define our attributes to be, but some useful ones are position, where the vertices are, and we probably have something like normal or color or UV or something. It's really up to us what we want to make. And then we want to bind the data to these attributes. So we want to say like, maybe this part here is the position, and maybe this part here is the normals or something. Maybe the color is even specified in some other VBO or something. It's really up to us how we want to map VBO or VBOs to these attributes. And this mapping is being kept track of by a vertex array object. All right, or a VAO. I should say vertex buffer object is usually called a VBO. Is that shorten the word? All right, so to recap, vertex buffer object holds the data. Vertex array object maps the data. All right, so that's very important. So vertex array object in themselves do not contain any vertex data. It only contains mappings. Fantastic. Then we're going to turn this into a draw call, where all of these vertices get grouped together. Like so. draw call. Now this part is a little bit more, nuanced, and we'll get into it later. But either we can just do a draw call, just kind of raw, I guess, and just like sort of map them out, as they are, or we can use something called an element buffer. So I'll do element buffer, where we have a little bit more control over how these vertices in the mesh are actually lined up. But that's fine. We're actually going to skip over this step a little bit and talk about that later. Okay, then these groups of vertices gets put into a vertex shader. So now we're entering the shading part of the pipeline. So we're going to enter a vertex shader. All right. And that's going to work on each of the vertices, all right? So it's get called, so the vertex shader gets called once for every vertex in the triangle, in the group triangle. And it's going to transform them onto screen. It's going to transform each of them where they're going to be on screen. And it works in something called normalized device coordinates. Normalized, that's not how we spell. Normalized, there we go. Device coordinates, or NDC. And it's not super important, we're gonna get into that later, but essentially it doesn't know about pixels. It doesn't know what the resolution of your screen is. It doesn't know anything. All it knows is the vertice's relative position to the screen. So it works on a -1 to 1 position system. So in the smack dab in the middle is going to be 0, and then the same thing for the y-axis. All right, so it takes these vertices and then transforms them into NDC space, which means like, these one to the left are going to be a little bit like negative 0.3 maybe in the x-axis, and this one is going to be, negative 0.8 in the y-axis, and positive 0.8 in the x-axis, and so on. So it transforms them into NDC space. Important to note, they don't work in pixels. All right. And then, of course, but we need to work in pixels because, our screen has pixels, and that's where the rasterizer come in. Rasterizer, sorry, not rasterizer. So rasterizer. Sounds like a transformer. So a rasterizer takes this normalized device coordinates and maps them to pixels and sort of figures out from these edges. I'm going to draw the extra edges here, actually. There we go. From these edges, which pixels should be lit up and which pixels should be dark or not worked on. And that's the rasterizer's job. We actually don't write that one. That one is just coded into the pipeline. I don't think we have any control over the rasterizer. But the rasterizer output is being mapped or fed into the fragment shader. And let's draw them out. So let's make a few pixels here. These pixels, the rasterizer decided that these pixels here are going to be lit up. Let's just make a few of them, maybe like that. Sort of approximates the shape into pixels. That maybe. Let's just draw a few more. I think you get the point. The wonkiest pixels you've ever seen. All right, there we go. A little shark fin triangle. Okay, just pretend it looks like that. Okay, so it's approximating the triangle into pixels. And each of these little pixels in OpenGL, they're called fragments. All right, so this is called a fragment. All right, and the fragment shader's job is to work on each of these fragments to figure out how they're gonna look. What's the color gonna be? What's the depth gonna be, and so on. The fragment shader handles that stuff. So it's the final sort of toucher-upper of how the surfaces of our game are gonna look. So again, Vertex Shader works on each individual vertex to define the surface, and the fragment shader or the pixel shader works on each individual pixel or fragment. And that's the last step. Then after that, it's drawn to screen. So, ta-da! So nice. Great. So that's the broad overview of a simple pipeline. Going from mesh data with the vertex buffer object, the vertex array object, turning that into a draw call, ordering the vertices into faces or triangles, the vertex shader transforming each of the vertices, rotating them, scaling them, whatever it needs to do. That's get rasterized into pixels, turn into the fragment shader to get lit, and then put on screen. Great. So we're gonna start, at the very beginning with vertex buffer objects, and then just move our way up. So let's go.